In this video, we'll talk about what a perfect fifth is, what kind of interval that is, and how it relates to the circle of fifths, transposition, and major scales. The circle of fifths looks like this. It's a very handy graph that shows us what accidentals scales need. It operates in a very logical way, and once we understand how it does, we can make our own circle of fifths for reference, and eventually we can just visualize it in our minds. It's a useful tool and a good way of understanding scales, keys, and transpositions. So if it looks scary right now, don't worry. We're going to get to a point where hopefully it doesn't look as scary. Before we get to the circle of fifths, let's review a couple of things. First, an interval is the distance between two notes. In our discussion of major scales, we saw that the intervals between adjacent scale degrees in major scales are either whole tones or semitones, and that the specific sequence of two whole tones, one semitone, three whole tones, and another semitone, which you have right here, make up the inner structure, the DNA or the recipe, if you will, of a major scale. Second term that we need to review is transposition. Transposition is the act of moving a pattern or a sequence of intervals to a different starting point, a different starting note. If we move the major scale's whole tone semitone pattern from C here to any other note, like in this case G, we can get a major scale starting on G, like in this case, or really any other note. The C major scale sounds like this. At scale degrees 1 through 7, and then ending on scale degree 1, an octave above where we started. Transposed to G, the G major scale sounds. So you see that it sounds basically the same. It's the same structure or DNA, the same intervals are there. It's just that we're starting at a different note. And because we do that, then we need to alter some of the notes, add accidentals, sharps, flats here and there, so that that sequence of intervals is maintained. So we know two intervals, semitones and whole tones, but now it's time to learn about another interval, which is called the perfect fifth. We will talk more about all kinds of intervals and how they're named at a later occasion, but for now I think we just need to focus on the perfect fifth and just accept the name, the terminology as it is, just because it's so necessary for us to understand the idea of the circle of fifths. To calculate the distance or the interval of a perfect fifth, you must first count 5 letter names from your starting note, either up or down, to get the name of the next note, the letter name, and then you make sure that the 2 letter names are 7 semitones apart. If there are more or less than 7 semitones, you must apply an accidental to the second note, so that there are only, no more, no less, only 7 semitones in the mix, right? So let's calculate an ascending perfect fifth from C. So here we have C. The 5 letter names, including the starting note, are these: C, D, E, F, G. So G is a fifth above C. Next, we need to verify if there are indeed 7 semitones between C and G. The best way of verifying or calculating the number of semitones between two notes is, in my opinion, by visualizing a piano keyboard. Right? If you can do that in your mind, great. If not, you can look at the screen, get an image for reference, or draw your own piano layout of a keyboard. It shouldn't be too hard to draw it up, because it's basically all white keys, and then you have groups of 2 black keys, and then no black key, 3 black keys, and then no black key. Right? That's the pattern we saw in one of our very first videos. So C to C sharp is 1 semitone. C sharp to D is 2 semitones. D to D sharp 3. D sharp to E 4. E to F, notice that there's no black key. E to F is 5 semitones. F to F sharp 6. F sharp to G 7. Therefore, C to G do indeed make up a perfect fifth. Perfect fifths can also be descending, right? You can calculate your first note and then go down from that first note to get a descending perfect fifth. So if we do that on C, notice that I've changed the clef here, so I'm starting on middle C once again, and I'm going down this time. So I'm using, to avoid using the ledger line since I'm starting on middle C, I'm using the bass clef in this case. If we do that and we start on C, we count the 5 letter names including C. We have C, B, A, G, F, right? So we land on F. So we know that F is a fifth down below C. Is it a perfect fifth? So for that we must count the semitones. C to B, 1 semitone, B to B flat, 2, B flat to A, 3 semitones, A to A flat, 4, A flat to G, 5, G to G flat, 6, G flat to F, 7 semitones. So indeed, between C and F, we have a fifth and we have 7 semitones. So it is a descending perfect fifth. We've been pretty lucky so far. Both of our examples didn't need accidentals because they already had 7 semitones. Let's look at 2 examples in which we do need to involve accidentals to see how that works. First, let's calculate an ascending perfect fifth starting on B. Here you have B. It's sitting just below the first ledger line below the staff here. It's the B that is a step below middle C. And if we're going to go ascending, you must count 5 letter names starting on B. So that is B, C, D, E, F. Once we count the semitones, B to C1, C to C sharp 2, C sharp to D3, D to D sharp 4, D sharp to E5, E to F6, right? There's no black key here, so it's 6. So therefore, between B and F, we do have a fifth because there are 5 letter names involved, but we do not have 7 semitones. We have 6 semitones. So that's a problem. That's not a perfect fifth. So we need to do something. We need to add an accidental so it does become a perfect fifth. We need to raise this distance, increase this distance from 6 to 7 semitones. So we go to the F that is the black key above that, right? Which we'll call F sharp. We're raising this F by a semitone to an F sharp, and thus between B and F sharp now, we do have 7 semitones. This is the sound of a perfect fifth. Listen to B to F, 6 semitones, and see if you can tell the difference. Right? It's a lot more dissonant, a lot more disagreeable, the sound there. There's your perfect fifth, B to F sharp, an ascending perfect fifth starting on B. Notice too that I did not call this black key, as I could have, a G flat, right? That's another possible name for this black key. And the reason for that is because perfect fifths involve only 5 letter names. Had I called it a G flat, I would have needed B, C, D, E, F, G, which are 6 letter names. So that's not what we want. Our last note needs to be an F. So it needs to be an F sharp at that. Now let's think of a descending perfect fifth starting on F. I've changed once again the clef here, just so we can get more accustomed to reading in both clefs. There's no real reason why I did it. I could have transposed all of this up an octave, and I could have done it in treble clef, but it's good to get practice with both clefs. If I go a descending fifth from F, counting 5 letter names, I have F, E, D, C, B. If I count the semitones, as I've shown here, I have only 6 semitones between F and B. It's once again that disagreeable or dissonant sound, or at least more dissonant than the perfect fifth. So we need to increase this distance from 6 to 7 semitones, right, by adding an accidental to the second note. We start on F, ending on B would give us 6 semitones. We then lower that B by a semitone, having a B flat instead, and now we do have 7 semitones. So F to B flat is now a perfect fifth, a descending perfect fifth. If this seems like tangential or a sort of detour from our topic of the circle of fifths, it's not at all unrelated. Understanding perfect fifths eliminates the stress of memorizing the circle of fifths, which a lot of people will have to do or will do eventually. But if we know the logic and if we get a good grasp on perfect fifths, then it's not necessary to memorize the circle of fifths like that. So in our previous discussion, we transposed C major to G major. I play that for you, in fact, at the beginning here of this video. Or in other words, I applied the whole tone semitone pattern for major scales that you see below in all of these instances, starting on G, right? What we got was a scale that utilizes all white keys, G major, no accidentals, except for scale degree 7 here, which is an F sharp. Now, if we transpose G major up by a perfect fifth, so we get the pattern of whole tones and semitones of a major scale and start it on a perfect fifth above that, D, right? What will happen? Notice that as we do so, we now need 2 accidentals in D major so that the notes can abide by the pattern. E to F would have been a semitone. Remember, there's no black keys in between them, but we need a whole tone in there. So we make that F an F sharp. And likewise, B to C, since there are no black keys in there, would have been a semitone, but the pattern dictates or mandates a whole tone. So I increase that distance by a semitone by making that C a C sharp, and then everything else falls into place. Here's G major. And here's D major with F sharp and C sharp. Right? It sounds basically the same. They're the same intervals, but starting a perfect fifth higher. So C major uses no accidentals, G major uses 1 accidental, F sharp, and D major uses 2 accidentals, F sharp and C sharp. Can you already see a pattern emerging? Notice that C to G makes an ascending perfect fifth, 5-letter names starting on C and 7 semitones. G to D, like I told you before, also makes a perfect fifth, 5-letter names from G to D, G, A, B, C, D, and 7 semitones between G and D. And here you need 2 accidentals. Notice also that all of the accidentals I've needed so far are sharp. So the pattern is this. Every time you transpose a major scale up by a perfect fifth, that is by using an ascending perfect fifth, you will need 1 additional accidental, namely an additional sharp. Right? So that's the basic idea. So if I would transpose this D major scale up by a perfect fifth, then I would need not 2, but 3, 1 more than here, 3 accidentals, 3 sharps. Let's see if her theory stands up. Let's count 5-letter names starting on D, D, E, F, G, A. Are there 7 semitones between D and A? Yes. You can picture that in your mind by visualizing a piano keyboard, or you can pause the video and count, but trust me, there are 7 semitones between D and A. So it is a perfect fifth. So the scale we're looking at is A major. Let's apply the major scale D and A starting on A, A to B whole tone, B to C sharp, whole tone, C sharp to D semitone, D to E whole tone, E to F sharp whole tone, and then we need another whole tone. F sharp to G would have been a semitone, so we need to increase the distance from F sharp to G sharp to make it a whole tone. G sharp to A is a semitone. As we predicted, we need 3 accidentals, or more specifically, 3 sharps. C sharp, scale degree 3, F sharp, scale degree 6, and G sharp, scale degree 7. Notice one more thing. We do need an additional accidental when transposing the scale up by a perfect fifth, but the other accidentals were already present in the previous scales. So if we think of A major containing C sharp, F sharp, and G sharp is unique at this point to A major, but F sharp appeared in both G major and D major, F sharp and C sharp appeared in D major, right? So the basic idea here is that when we transpose a major scale up by a perfect fifth, we will need all of the accidentals that had been used in that previous scale plus a new one, right? And we know what the new one is by applying that pattern, that DNA of whole tones and semitones to that new transposed scale. If we keep transposing the major scale by ascending perfect fifths, like I've done here with the arrows, we go from A to E major, and notice how we do need 4 sharps this time rather than just 3. And the D sharp is a new sharp, but the other 3 were already present in A major. Transpose E major up by a perfect fifth to B major. Once again, I now need 1 additional sharp, 5 sharps in the B major scale, and they were all present in A major except for A sharp, right? F sharp will have 6 sharps, and then finally we get to C sharp major, which is a scale in which all 7 scale degrees receive a sharp. If I will play them, all of the scales you see in front of you, you'll notice how they sound the same because of the same intervallic structure, but they're just starting at different notes. D major, A major, E major, B major, F sharp major, and finally C sharp major, in which all notes have a sharp. So here's how that pattern of transposition looks like on a graph on the circle of fifths. This is a semicircle of fifths, if you will, almost. It's a little bit longer than a semicircle. And it contains the scales with, first the scale with no accidentals, which is C major. And then that C major is transposed by ascending perfect fifths time after time until we arrive at a scale in which all notes, all of the 7 scale degrees, have a sharp, which is C sharp major. On the outside of the circle, you see the name of the major scale, represented with an uppercase letter. And on the inside of the circle, I've placed for you here the accidental that is new to that key at that point, right? So C major has no sharps. G major has 1 sharp, F sharp. D major will have 2 sharps, C sharp and whatever came before, F sharp. A major will have 3 sharps, G sharp, C sharp, F sharp. E major will have 4 sharps, D sharp, G sharp, C sharp, F sharp, etc. So far we've only transposed the major scale by ascending perfect fifths, but we can do the reverse. We can transpose the major scale by descending perfect fifths. The exact same pattern applies with just one difference. The scales now, the additional accidental we'll need are not sharps, but flats, right? So every time we transpose a scale down, starting on C major, by a perfect fifth, we will need an additional flat. So let's do C major and transpose it by a descending perfect fifth to F major, like you see here. We apply the same pattern of whole tones and semitones, and we arrive at a scale that utilizes 1 flat, B flat. Here's C major. Here's F major. Once again, the sound is very, very similar, if not, the same, but just starting at a different location. To preserve that sound, to preserve that intervallic structure, we needed that B flat. Now, if we keep transposing F down by a perfect fifth, we will need an additional flat each time we do that. A perfect fifth below F, then, we need to count 5 letter names: F, E, D, C, and B. But F to B, there are only 6 semitones. We need that to be 7 semitones. So we increase the distance and make that be a B flat. So B flat major, then, there are 2 flats. We transpose it down by a perfect fifth to E flat major. There are 3 flats. A flat major, 4 flats, so on and so forth, until we get to the point where C flat major, all of the notes receive a flat, all of the 7 scale degrees. Here we have the other half of the circle of fifths, the counterclockwise one, where we're transposing scales by descending perfect fifths. Like we've seen previously, each successive scale has one more accidental than the previous one more flat, right, than the previous one, and it utilizes that flat plus all of the other flats that appeared before it. So F major, there's a B flat. B flat major has 2 flats, E flat and B flat. E flat major has 3 flats, A flat, E flat, B flat, etc. Notice also how every new flat is a perfect fifth below the previous flat, right? B flat, E flat, A flat. So we're transposing the scales down by perfect fifths, and the new accidentals are following the same pattern. Each new accidental is a perfect fifth below the previous one. Here's the complete circle of fifths. If it looks scary, once again, don't worry. The more you look at it, the less scary it gets. And lots of people actually dread the circle of fifths, even professional musicians. But I think that once you understand its logic, how it works, it's actually not that bad and very useful. One last remark. I've kind of highlighted an area here of the circle of fifths where we have 2 different scales per spot, right? So these scales, or as we'll later learn to call them, keys as well as the accidentals you see here, these are called enharmonic keys. Remember how we defined enharmonic? Basically, it means that they sound the same, but they would look different because they use different accidentals and different notes. That's what these keys are. This is perhaps the most terrifying part of the circle of fifths, just because there are lots of accidentals involved. But really, it's not that bad. These scales, by the way, if I could demonstrate this, I will play for you, for example, the scale of B major, using B, C sharp, D sharp, E, F sharp, G sharp, A sharp, and B. Right? So it has that sound. If I would play the same thing but in the C flat, it would be C flat, D flat, E flat, F flat, G flat, A flat, B flat, C flat. It sounds the same, it's just using different letter names. Therefore, they're enharmonic keys. Okay, thanks a lot for watching. In our next video, we'll talk about what keys are, what the relevance is of key signatures and how to properly write them, and we're going to link our discussion of major scales in the circle of fifths to the idea of major keys. Okay, see you next time.